In this question, we have to solve radicals. So I have written the steps to follow on the side over here. We have to isolate the radical on one side of the equation. Okay, whenever you have a radical in the equation, try to isolate it. So in this case, we have to make sure that square root of x is on one side and this x goes to the other side of the equation. So to do that, we will subtract x on both sides. We're going to minus x here and minus x here, and x will cancel. And I'm going to write it over here. Square root of x is 6 minus x. Now that's the first step. We have to square to cancel the square root. If it's a cube root, you'll have to raise to the third power. If it's a fourth root, you have to raise to the fourth power. So since here it's a square root, we are going to raise this to the second power. Okay, so to the second power over here and to the second power over here, and we get so when we try to square 6 minus x, you can actually multiply it, or you can distribute and multiply and get it like that. You like 6 minus x times 6 minus x. You can distribute, combine like terms. 6 times 6 is 36. 6 times negative x is negative 6x. Negative x times 6 is negative 6x, and then x times negative x is positive x squared, and then we write it as 36 minus 12x plus x squared. The easiest way to do this, though, we don't always have to remember to distribute and multiply like that. We can also use the identity, which is a minus b the whole square, which is equal to square the first term, use the middle term sign negative, and then multiply all of these three, including the 2 times a times b, and then plus square of the last term. You can follow this rule. We get the same answer here. So when I square the first term 6, I get 36. Minus is the middle term sign. We use the minus. Multiply all three of them together. 6 times 2 is 12, times x is 12x, and the last term squared, plus x squared is just x squared. And on the right side of the equation, when we square a radical, this radical and the square root cancels, and we are just left with the x. So we squared the left side, we got this. We can either distribute and combine like terms and do it the long way, or use a shortcut identity to find the left side of the equation. And then we got our equation like this now. Now what we have to do is, we can solve this several different ways, by factoring, by quadratic formula, or any other way that you would like to, whichever one you prefer. It does not really matter. So I'm going to put all the x on one side. So I'm going to have to cancel this x now. So I'm going to do minus x. I'm going to write x under x term like that. Bring down the equal over here just like that. Cancel the x. We have 36 minus 13x plus x squared is equal to 0. So I want to arrange this and write this in the standard form. Highest degree term first, then the linear term, then the constant term is equal to 0. So these two steps are the same. I've just rearranged the terms. So if you look at this, you can either use quadratic formula if you are comfortable with that, or I think there's an easier way to do it. We can find two numbers whose product is what? I'm just going to make some space for me over here. Two numbers whose product is 36. When you have to multiply, you have to get 36, and when you have to add, you have to get negative 13. So 36 can be, we can get 36 by multiplying 1 times 36, 2 times 18, 3 times 12, 4 times 9, and that's about it, right? No, 6 times 6 is also 36. So these are the possibilities of 36. We know that this pair out of these, this pair can actually give me 13 if I call them both as negative numbers. Negative 4 and negative 9 can give me negative 13. So those are the numbers we're looking for. So I can factor this as x minus 4 and x minus 9 is equal to 0, which gives me my solutions to be we know that -4 is a 0 only if +4. -4 is a factor, that means +4 is a solution. That's what I meant to say. And -9 is a factor, means +9 is a solution. So these are the two supposedly the solutions of this equation. Now we have to absolutely go back and check number 4, step number 4. We have to check before we can decide that if they are actual solutions or not. So how do we do that? I need some space over here, so I'm going to erase some of the stuff over here. So let's do our checking. Get the color for that. So let's plug back. Let's first check the solution of 9. Let's check x equals 9 if that is correct or not. So this equation says that 6 is equal to x plus square root of x. So instead of x, if I plug in 9, 9 plus square root of 9 will become 9. And we know that square root of 9 is 3, 9 plus 3 is 12. They are not equal. So 9 is not a valid solution. Not a valid solution. Or there's another name for 9. It's called an extraneous. It's called an extraneous solution. 9 is an extraneous solution. Now let's try to find check for 4. Okay, check for 4. So 6 is equal to, instead of x I plug in 4 now. 4 plus square root of, instead of x I plug in 4. So 4 plus square root of 4 is 2. 4 plus 2 is 6. They do match up. 6 is equal to 6. This is correct. Here 6 is not equal to 12. This is false. This was false, so this ended up being an extraneous solution. This, when you checked for 4, we got a true equation. So we can say that 4 is a valid solution, or just a 4 is a solution. So now let's try another question. 3x is equal to 1 plus 2 radical x. Again, we have to isolate the radical on one side, so we have to subtract 1 on both sides over here. So we get 2 square root of x is equal to 3x minus 1. Now the next step, step number 2, is to get rid of the radical by squaring on both sides. So we're going to square and square. Okay, so this is, you'll use the identity a minus b. The whole square is first term square minus 2 times the product of both the terms plus the last term square. Okay, so first term square will be 3x square. 3 square is 9, x square is x square. Sign of the middle term, when you multiply all of them, we get 6x. Last term square, 1 square is just 1. Now on the right side, this square is for the 2 as well as for the x square. So 2 square will be 4. Square root of x square will just be x. So now we can rearrange this to a quadratic equation. 9x square. We can combine the like terms by bringing the 4x, subtracting the 4x on both sides. Minus 4x. So that term right there will become 10 for us. So we're going to do that. Not plus, it's minus. It's minus 10x plus 1. This will cancel to get you 0. So now we can just solve this. We can either use quadratic formula, or I'm just going to use grouping here. We have to find two numbers whose product is, if you have an equation of the form ax square plus bx plus c is equal to 0, you have to find two numbers whose product is of the form a times c and sum is of the form b. So in this equation, this is our a, this is our b, this is our c. So ac would be 9 times 1 is 9, sum would be negative 10. What are the two numbers? When you multiply 9, when you add 10, I think it's -9 and -1. So we're going to use those two numbers to split the middle term so that we can rearrange and group this and factor this and solve. Let me show you how to do it. 9x squared, instead of -10x, the middle term is written as -9x minus 1x. So we use the numbers that we just picked to split the middle term. Plus 1 is equal to 0, and then we group and we factor. So let me do every step in a different color. I think it will really help. So like that, group the first two and the last two. Both of them have 9x as the GCF. We are left with an x minus 1. 9 is gone, x is gone, just a -1. We have nothing, it's a 1. Out of both of these, I'm just going to take a -1 away. So if I -1, there's an invisible 1 here. Remember, if the -1 is gone, I just have the x. From a positive, if you take away a negative, you have another negative. And if the 1 is gone, you're just left with the 1. So when we factor these two terms again, the GCF is what we have in the parentheses. So if I factor out x minus 1 from both these terms, I have a 9x left and I have a -1 left, which is equal to 0. So when I solve by setting each factor to 0, I get x as +1 and x as +1 over 9. How do I get this +1 over 9? Just a quick explanation. 9x minus 1 is 0. To solve for x, you add 1 on both sides, so you get 9x is equal to 1. Solve for 9, you divide by 9 on both sides, so you get the answer as 1 over 9. Just wanted to quickly explain that just in case if anyone was confused. So those are the two solutions, but we don't know if they are actual valid solutions or not. So let's do our checking process for this. So we're going to check. So when we check for 1 over 9 in the main equation, on the left side we have 3x is equal to 1 plus 2 radical x. So instead of x, I put 1 over 9 is equal to 1 plus 2 times square root of 1 over 9. And now, how do we deal with these fractions? We just have to cancel common terms. So what we have to do is 3 cancels 9 3 times. So we have 1/3 on the left side of the equation. On the right side, we have square root of 1 over 9 is 1 over 3. So you know that when you add this fractions becomes, I have 1 over 3 on this side and I have 1 plus 2 over 3 on the right side. So both these fractions are not the same. When you add, you don't get the same answer. So 1 over 9 is an extraneous solution. 1 over 9 is the extraneous solution. So we can clear that and we can check for 1 now. So when we plug in for 1, we get, when we check for x equals 1, we do get 3 times 1 is equal to 1 plus 2 radical 1. So 3, we're going to check, that's not a plus, I'm sorry, that's an equal sign. 1 plus 2 square root of 1 is just 1, so 1 times 2 is 2, and we get our answer is 3 equals 3, so this is the valid solution. Okay, but when you have two radicals in one equation, okay, the easiest way to do it is to make only one on each side. When you have two radicals on each solution, that is the best way to go. So I'm just going to I'm just going to write it like this. Just watch how I'm going to do this. X plus 3 is equal to 3 minus square root of x. I brought that one on one side and one on the other, and then square on both sides. That's the easiest way to do. You can solve it the other way also, but it will just be longer. So use the identity a minus b the whole square to solve this. You get 9 minus 6 radical x plus x. Cancel the common terms. You get 9. When you do minus 9 minus 9, you get -6. -6 square root of x. Cancel the common terms. You get 1 as square root of x. When you square on both sides, you get x equals 1. which is your solution. Then you plug